All right, we are recording. So we're going to start on section 4.1, which is the law of sines. So here up to now, we've been solving right triangles. Now we're going to try to solve oblique triangles where we know either two angles and a side or two sides and an angle opposite one of those sides. So the idea here is, here's what I want to make sure that we have kind of our labels down right. So if I have triangle ABC, capital A is going to represent angle A, capital B is going to represent angle B, capital C is going to represent angle C. And then what we can do is we can use lowercase letters for the side that's opposite. So the side that's opposite angle B is lowercase b, the side that's opposite A is lowercase a, and the side that's opposite capital C is lowercase c. So C is going to represent this whole side here. Now, the nice thing about this is when we have a triangle like this, we can always turn it into two right triangles by dropping down a perpendicular. And so when we have, so we can create two right triangles in any triangle just by dropping down a perpendicular there. So the sine of B, of angle B in this case, is going to be the hypotenuse, H, divided by A. So that's your opposite, your sine of B. Yeah, so that's your opposite over your, in this case, the hypotenuse is A. Which kind of gets a little confusing because we're doing this. If we look at the sine of angle A, that's going to be the height H divided by the hypotenuse, which is B in this case. And so by solving these equations, you're going to get the height of the triangle is going to be A, side A, times the sine of your angle B. And you're also going to get that your height is going to be B times the sine of A. So we can set these equal to each other because the height is going to be the same in either case. And we've got A over the sine of A equals B over the sine of B. Okay? And so this leads to the law of sines. And so this is what you're going to do. And so this also works for side C. So A over the sine of A equals B over the sine of B equals C over the sine of C. Okay? So let's do an example here. So I want to solve triangle ABC if angle A is 42 degrees, angle B is 63 degrees, and side C. So notice we're using capital letters for the angles, and then we're using small letters for the sides, okay? Now, side C is 18 centimeters. Now, we remember, hopefully, that what is the sum of the angles of a triangle? Let's see if we can ask Josue. Do you remember the sum of the angles of a triangle?
Yeah, it's 360.
No, it's half of that.
Oh, 180.
180, yeah. So the cool thing is, if we've got two angles, we can figure out the third angle by just adding those two together and subtracting. So if you've got two angles, you can always figure out the third angle. And so angle B in this, let's see, we've got A and B, so angle C is going to be 75 degrees. Okay? So now that we've got that, there we go. So your sum of your angles of a triangle is 180 degrees. So angle C is 75. So now, so we've got all three angles. Now we need to find the other two sides. So Josue, can you use the law of sines to find the lengths of the other two sides?
Yeah, but can you roll out a little bit down?
Okay, well, I'm trying not to give away the answer. Is that better?
Yeah, thank you. Then I'm looking for C, or
Well, because C was easy to find because the sum of the angles is 180. So we've got angle C is 75 degrees. So now we're trying to find sides. So find sides.
B and B. Should I use the formula that is above?
Right.
Okay, then it's gonna be C equals A over sine of A over sine of C. No,
A divided by the sine of A equals B divided by the sine of B.
okay.
Okay. So now we just need to plug in some numbers.
Then it's gonna be 42 over.
Actually, let's not use B over the sine of B. Let's use C over the sine of C.
Okay.
It'll make our lives a lot easier.
It's gonna be 42 over the sine of A, but I don't know how to get the sine of A.
So we don't know what A is, right? But we know that the sine of 42 equals
C over sine of 75.
Yeah, and what's C?
18.
18 sine of 75. Okay. So now we can solve for A, right? And how do we solve for A?
It's going to be A equals 18 over the sine of 75.
18 times the sine of 75.
Or 18 times. Oh, okay.
Yeah.
Okay. Over
Why is it times?
Sorry. No, you're right. You're right. I should have had to divide that.
Oh, okay. Yeah, I got confused with that.
Yeah.
Okay. Over.
Times
sine of 42.
Okay. And so now we can plug that in our calculators, and we will get that side A is 12 centimeters. Okay. So since Josue did that, how about Cameron Ravert? Can you help us find side B?
All right, so we don't know little b, so it'd be b divided by sine of 63 is equal to can you scroll up a little so I can see the top of the triangle?
Oh, try not to give away the answer. There we go. Sorry.
So it'd be b divided
Maybe
by
I can get rid of some of this
sine
stuff.
of 63, and then it would be 18 divided by sine of 75, and those are equal to each other.
Here, see if we can do this. Yeah, so b over the sine of 63 equals what?
It would be 18 over sine of 75.
Okay. And then to solve that, we would get
Hold on, let me get my calculator.
Oh, just tell me what to write before we.
Wouldn't it just be? Wouldn't you multiply the 18 divided by the sine of 75 by sine of 63.
Yeah, exactly right. Okay, perfect. And then when we do that, we're going to get 17 centimeters roughly. Okay. So I guess we'll probably have to start using calculators again. Did you guys like not having calculators on that last test or not? Probably didn't. No comment. All right. Okay, so let's talk about the ambiguous case of side-side angle. Okay. So remember, as we were doing the law of sines, if we've got two angles on the side or two sides and an angle opposite one of the sides, that works well. Okay. Now the problem is, what if we do the ambiguous case of side-side angle? So we're given two sides of a triangle and an angle opposite one. This is not necessarily a unique triangle, okay? So let's talk about case number one. Angle A is acute, and so we've got some cases here. So you can see here, well, this is case one, scenario one. If side A is less than h, the height of the triangle, you cannot have a triangle. It just doesn't exist because this side is much too short. Okay. If side A equals side H, well, that's nice because you have a right triangle. You'll have only one triangle because A equals H. If A is greater than H, okay, then, but it's less, so if A is in between the height of your triangle and C, you're going to have two triangles. You could either have this obtuse triangle here, ABC, or you could have this acute triangle ABC. And so you've got two cases, you've got two triangles you can draw, either this obtuse triangle here or this acute triangle here. And so that's if your A is in between the height and side C. Okay, so you'll notice here we've got a C prime and a C double prime. Okay. Now, if A is greater than or equal to C, then you're going to only have one triangle. So, so these are the four situations that you can have with case number one. So, just reviewing once again, if side A is shorter than your height, there's no triangle possible. If A equals the height, you'll have one triangle and it will be a right triangle. If A is in between the height and side C, you're going to have two possible triangles. And if A is greater than or equal to C, you're going to have one triangle and it will not be a right triangle. Okay, so this is where your side A is much larger than side C. Okay. Now we also have a second case, and that's if angle A is obtuse. Okay. So if A is less than or equal to C, then you're going to have no triangle. It's just impossible. Okay. Now notice in this case, your height is outside the triangle because we've got an obtuse angle here. So if A is greater than C, so the side A is greater than side C, okay, you will have one triangle. Okay, so that's going to be, so we've got case one where angle A is acute, and case two where angle A is obtuse. Okay, so I think kind of the thing that we need to pay attention to is A in relation to side C in both cases. So it's better, generally better, if your angle, if A is greater than C, you're only going to have one triangle. Okay. If A is in between your height and C, you've got two possible triangles. So as we're doing this, you guys are going to want to do these to pay attention to A and C. Okay, so solve triangle ABC if B is 32 degrees, A is 42, and B is 30. Okay. So when we're doing these, you're definitely going to want to draw out your triangle. So we've got angle B is 32 degrees, A is 42, and B is 30. So this is a little we've kind of relabeled these two triangles, but as you can see here, okay, the height, so A is going to be longer than your height of the triangle. So you've got two different triangles you could have. You could have triangle ABC or triangle ABC in this way, okay? So there's two different triangles that we could have in this situation. So let's assume that angle A is obtuse. So how would you solve? And when I say solve the triangle, we need all sides and all angles. Okay. So let's ask, let's see here. Ivan, are you here?
Yeah.
Looks like we got a lot of people showed up later. Okay, so how would you, so let's assume that angle A is obtuse. How would you find the other sides and the other angles? And I'll let you pick which one you want to do first.
I don't know.
Okay, so we're going to use our law of sine. So here, let me copy this here. This whole chapter is going to be law of sines. So next time I ask you that question, you're going to say, I'm going to solve it with the law of sines.
No, I know that. I just don't know how to use it completely. Like.
Okay, so
So would it be sine of 42 equals?
nope.
No.
Remember,
32, because that's the only one that we know.
that's the only one that we know. So we were going to start with B over the sine of B, right? So B over the sine of B. So B is what in this case?
B, like B minus, or?
So if capital B is 32 degrees, then the B is going to be the side opposite of your angle B.
So it's 30.
So it's going to be 30 divided by the sine of 32 is going to equal what?
It's going to equal to 42, the sine of A.
42 divided by the sine of A. I'll use a capital A there, okay? So now, how would you solve for the sine of A?
Would I have to use the inverse sine to move it to the other side?
No, not to move it.
So I would divide by.
Let me just mention one other thing. This might make it a little bit easier. The reciprocals all work as well. So if I did the sine of 32 divided by 30, and the sine of A divided by 42, that makes your math a little bit easier.
I thought that when we wanted to like get rid of a sign on one side, we use the inverse sign. The inverse of it, no?
Okay, so we'll do that eventually, but not yet. I want to get the sine of A all by itself.
Times 42?
Yeah, both sides by 42. So then the left side becomes 42 sine 32 divided by 30 equals the sine of A.
Now you do the inverse of sine?
Now we do the arc sine. I guess I could spell it out. Okay, does that make sense?
Yeah.
Now, here's the problem with that, though. Let's see here. So when we do that, we're going to get the sine of A equals that, just like we said, which equals 0.7419 radians. So your angle A is either going to be, so when we do the arc sine, okay, we're probably going to get 48 degrees on our calculator, okay? So that's actually this angle here. So that's going to be 42 degrees, 48 degrees, okay? Now we got to remember also, because angle A can be obtuse, 180 minus 48 is going to be 132. So yeah, remember this is the case where we've got two different triangles. Okay. So
and we want to include both of those potential angles.
Yes. Yes.
Okay.
And so the idea here is,
where would the 132 fit in that figure 4.5?
so the 132 would be right here.
Okay.
Okay. Now, a couple of things that we didn't do. So let's think about this for a second, because there's two different triangles we can do. We probably should have labeled that A as A prime. Okay. So the nice thing about, or what makes this easy in this case is if, okay, so we've got angle B, so B equals 32. If A equals 48, what does 48 degrees, what does C have to equal in that case?
$100 degrees.
100 degrees, okay? And if B equals 32 and A equals 132, what does C have to equal in that case?
16 degrees.
16 degrees, okay? So then we could use that. So once you've got the two angles there, and it's funny because that, so these are two different triangles we could have. Then we could find the side of side C. So C is either going to be really short, and if it'll be short if you've got a 16-degree angle, or C is going to be really long if we have A is or C is going to be really long. So we could do that. Okay, does that make sense? In fact, let's finish that off just to make sure that we're all good on that. So that was Ivan. Mason, can you, I don't know which triangle you want to use in this case, the top one or the bottom one.
Doesn't matter to me.
Why don't you do the top one and we'll have somebody else do the bottom one.
Okay, cool.
So if we assume, and I'll make this in yellow, okay, so if we assume that our
Okay.
angles are here, how would we find side C?
So we'd set sine C, C over sine of C equal to one of our other ones that we know. So
Okay,
use
so
B.
C over the the sine of 100
Yep.
equals
32.
32 over
The sine of, oh wait, that's the angle. So we'd have, let's see, what's our side be? So 30 over sine of 32.
yeah, 30 over the sine of 32. Okay. And I'll assume you guys can plug it in your calculator properly. Okay. So, oops. So that's going to be the answer in yellow. And then if we do this in green, okay, if we assume that's your triangle, how would you do that one? So that was Mason. I'm losing my thing here. Nicole,
Yep.
are you on camera
So-
today or no?
Sorry, say that again.
Are you on camera today?
Yeah. Can you?
Oh,
I can see
Which one?
myself. I don't know why. Let me see. I can close it and open it.
that's okay.
Hmm.
Yeah, I don't see you today for some reason. That's weird. Okay, so anyway, it's hard to have this all on the same because it just takes too much. But so you got triangle. Oh, you got the green triangle now.
Yeah.
So
So I just do the same. I start with the sine of c. So little c over sine of 100, and then I'd say,
no, it's not the sine of 100
or
anymore.
16. My bad.
16
16.
equals.
And then I would just do 30 over 32 over sine of 32.
Okay. Perfect. And so that would be the green triangle. Okay. Well done. All right. So now let's solve triangle ABC. If A is 57 degrees, A is 15 feet, and C is 20 feet. Now, we've got, so as you can see here, sometimes this might be hard to do if you don't have this nice picture here. You can see this is an impossible triangle to solve. Okay, which you may not know especially if they're giving you this without the benefit of a picture. Okay, so so assuming you don't have this picture and you don't know that this is an impossible triangle, when you're doing this, if we use the law of sines, you can basically, the sine of C is going to be 20 times the sine of 57 degrees over 15, which equals 1.1185. Okay. Well, obviously the sine of C cannot be greater than 1. So now, so even if you don't have this nice little picture here, if you get a value, if you get the sine of C equals a value that's greater than 1, you're going to know that there's no solution. And that basically this side is too short. Does that make sense? It's hard when I can't see you guys. Okay, hopefully it makes sense. Okay. All right. Okay, so let's do another one here. Radio antenna is 85 feet high. It's located on top of an office building. The distance AD from the base of the building is 26 degrees, and the angle of the antenna is 16 degrees. Okay, so basically we've got a bunch of triangles here. Okay, so you've got this triangle ADB, you've got a triangle ACB, and so if we know already that the height of the building is 85 degrees, how can we use the law of sines to figure out the height of the H of the building. Okay, so we just picked on Nicole. She's probably glad that Tate's going to get this one. Well, Tate might not be happy about that. So
are we given the distance AD?
Does not look like it. Maybe we have to, do we have to know that? Let me think about that. I wonder if I forgot something there. Here, let me peek at something really quickly.
We can figure out angle beta just by subtracting 26 minus 16. That's going to be 10 degrees.
Correct. So angle beta is 10 degrees. Actually, I think, yeah.
85.
Oh. I also gave you another hint there, which I didn't mean to give you, but that's okay. Okay. Yeah, we don't know the distance AD. But yes, you're correct. So we've got angle. So we do know, since this is a right angle here, that's 90 plus 90 minus 26. So this angle here is 64 here. And then this angle beta, as you mentioned, is 10 degrees. Okay. So if this is 10, so we've got 90, we've got 26, and so therefore this one is 64. So we've got this angle, so we've got all three angles here, here, here. Okay.
And we're finding.
We need to find the height
H.
of the building H. So we're looking for ACD, basically.
Okay.
So yes, we've also got this angle here if we want to figure that out. Actually, yeah, we should be able to figure out all the angles.
Okay, so we don't have any of our side lengths, at least in full. We have a partial, I guess, yeah, from that triangle. Okay,
Yeah,
so
we
from
got
the
this
little triangle, we have side A, which is 85. So we can do 85 over the sine of 10.
85 over the sine of 10.
And that can equal. What side would be the best one to figure out?
Probably
Well,
this one, because once you've got this side is common to both of these two triangles.
Okay. So that's going to be side B.
I'm going to call it AC. How's that?
Okay.
Then we know exactly what it is.
AC over the sine of 64.
Perfect. Okay. So once we've got that,
Multiply the sine of 64 to both sides.
Yep.
85
So
over.
AC is going to be 85 sine 64 over sine 10. Okay. So that's whatever that number is, but you can actually just reuse that. Okay. So this is side AC. You might also actually tell you what I'm going to do. The problem is my calculator always does it in radians, not. That's all right. Okay. So now we just need to find the side H here, right? So basically, we're going to use the law of sines twice on this one. So how do we get H?
Side H, we've got 16 degrees. H over the sine of 16 is equal to, or no, it's a right triangle. We don't need to do that.
You're right. We could if we wanted to, but because it works with right triangles just the same.
We've got, my scribbles aren't making sense. We've got 90 degrees, 16 degrees, and we're not sure on that one yet.
Here, I'm going to put AC over the sine of 90, right? And what's the sine of 90?
The sine of 90 degrees is 0. No,
it's
1.
It's 1. So now I just got the side of AC, which AC is this right here. So I'm going to substitute that for that. And then I just need to solve for H, right?
I'm a little bit slow. So we did the sine of AC because sine is opposite.
No, we're just using the law of sines.
Okay.
Back up again. So we said the AC, because that's this side here. AC divided by the sine of 90. Well, we know that the sine of 90 is 1, right? So this is just going to fall out.
Okay.
Okay. So the height divided by the sine of 16th is just this side here, because the sine of 90 is 1. So now I can substitute this in for AC, because we know that equals AC.
And then we multiply that by the sine of 16.
Exactly right. Okay. So
do we have
H,
to use the law of sines here, or could we just say, like, because it's the sine of 16, couldn't we just do the opposite, which would be H over the hypotenuse, which we found, which was AC?
well, essentially that's what we're doing.
Oh, okay.
Yeah. So H equals this times the sine of 16. And then we can plug that in to get whatever the answer is, which is 121 feet.
Cool.
Okay, does that make sense? All right.
It will once I do the homework.
Yeah, so this one basically you had to do the law of sines for this little small triangle first, and then you could do the same thing here. And just remember, I mean, even though it's a right triangle, law of sines still works. And it's nice because in this case, angle D is sine of 90, which is 1, and theoretically we all remember that. Okay? All right, so the funny thing is, I have to tell you, we went on a family vacation this weekend, and I told one of my relatives, I told him I was teaching trig this semester, and he goes, "So what is trig useful for?" And I said, "Finding the height of distant objects." So anyway, so this is a perfect example. Say that again.
Sorry, I just have a question about that. So I did that on my calculator and I got like 121 point a whole bunch of decimals. Do you want us to just round it to the nearest foot, or whatever the unit is that we're doing? Just round it to the nearest whole number.
Yeah, that's probably the best on this sort of a thing. Yeah, because you're always, anytime you use signs, you're always going to get a bunch of decimals. So that's why I put the little squiggle equal there. It's about 121 feet. Okay. Any other questions? All right. Okay, so now we're going to talk about navigation, okay, headings and bearings. So this is always a little bit interesting. So if you're in the Navy, any of you get in the Navy, you're going to talk about headings and bearings, okay? So in heading, we define as clockwise from north, okay? So if you are on a heading of 65 degrees, okay, so you're measuring 65 degrees from north, you're heading northeast, basically, okay? If your heading is 285 degrees, you're measuring that from north, you're going all the way around here, 285 degrees, so you would be heading northwest in this case, okay? So that's when we're talking about a heading, okay? Now, when we're talking about a bearing, bearing is defined as the acute angle formed by the north-south line and the line of the direction. So when we're talking about bearing, okay, if we're talking about a bearing of north, so north 38 degrees west, okay, so we're measuring this from north and we're measuring it from 38 degrees. So this is a bearing of north 38 degrees west. So you're going 38 degrees west of north, okay? Now, another bearing we have is south 15 degrees east. So if you're heading south 15 degrees east, that would be this blue line right here, okay?
Is heading also used for like planes, like aviation?
Yeah, aviation and Navy and both of those.
Okay.
So, so I know these are confusing when we're talking about heading versus bearing. And we're going to do a problem here that's going to use both, which is going to make it really confusing, okay?
I have a quick question.
Okay.
So is heading clockwise and then bearing counterclockwise?
So heading is always clockwise, that is correct.
Okay.
Bearing could be either clockwise or counterclockwise. It depends on what they are. So you're always measuring it from the north-south line, and it's always the acute angle from the north-south line. So if I were going south 15 degrees west, that would be here. Or if I were going north 38 degrees east, that would be here.
Okay.
So, yeah.
So your heading and bearing would only be equal in quadrant 1, essentially, between north and east?
Yeah, that would be true.
Okay.
But the thing is, when we're talking about heading doesn't have to be an acute angle. But yeah, what you said was correct. Okay, so one way to think about this is if I were to talk about I am heading 285 degrees, well, if we were to change that terminology to the bearing, okay, that would be north 75 degrees west. So 280. So a heading of 285 degrees would be the same thing as north 75 degrees west. Okay. Does that make sense? All right. So I gave you a couple of these. I have to tell you, unless you're Air Force pilot or a Navy pilot, none of you are ever going to care about this stuff, but there's a homework problem here. So let's talk
I've
about
flown flight simulators, so.
Okay, yeah. All right, so a ship is heading 330 degrees. Its first sighted lighthouse at a bearing. So notice we're mixing up our headings and our bearings in this one. At north 65 degrees west. Okay. So you've got your lighthouse here. Okay. We're measuring everything from north. So north 65 degrees west, that's your lighthouse. Okay. After traveling 8.5 miles, a ship observed the lighthouse bearing at south 50 degrees west. Find the distance of the ship to the lighthouse when the sighting was first made. Okay. Now, I know this is confusing, and so we're just going to go through this piece by piece. And honestly, I don't know that I'm going to do a lot of these, but we'll do it this time. Okay. Okay, so we're going to show that the angle CAB, so CAB, okay, that was your starting point here, is going to be, so we've got 30 degrees here plus 65 degrees here. So this entire angle here is 95 degrees, okay? Also, you can also measure here, we've got your
I got
bearing
you.
330 degrees, okay.
And
All
then
right,
we got
so
50 degrees there and 30. So that
yes.
angle C would be 20 degrees.
Yes, so BCA, okay, is going to be your 20 degree angle here. So that's what, so this angle here, BCA is 20 degrees, okay? And angle B, where we're ending up, is going to be 180 minus 95 minus 20, which works out to be 65 degrees. Okay? All right, so we're going to use triangle ABC and the law of sines to find C. Okay? So B over the sine of B equals C over the sine of C. So we've moved 8.5 miles. Okay? So that's going to be 8.5 miles divided by your sine of 65 equals C over your sine of 20. If we solve for C, C equals 8.5 sine 20 over sine 65, which is about 3.2 miles. Okay. I know that was a little bit tricky. So, gosh, I thought we were going to take longer to get through all this stuff than we did. But that just means I don't want to start on a new section today. So, do you guys have any questions about the law of sines or headings and bearings?
I do have a question. Could we go over one more time how A over the sine of A is equal to B over the sine of B? Like how we derive the law of sines?
Way back in the beginning?
Yeah.
Okay.
Just so I can get my brain around it.
So basically, if we have a triangle ABC here. So this is just a regular acute triangle, although it's easier to visualize with an acute triangle. You can have an obtuse triangle too, that's fine. Okay. So you can always drop, so if you have an acute triangle, you can always create two right triangles here by dropping a perpendicular here, okay? So I've got a triangle DCB that's a right triangle, and DAC is also a right triangle, okay? So if we're trying to find the height here, so if I've got the sine of b, that's going to be the opposite over the hypotenuse. Okay, this is your height h divided by your hypotenuse. Okay. Well, this same h also, instead of using angle b, I can also use angle a. So height is also going to equal, the sine of angle A is going to equal your height divided by this hypotenuse, because this is also a right triangle here, okay? Well, in both of these cases, this height is the same length on this triangle as it is on this triangle.
Okay.
Okay, and so when we set this h equal to each other, then you've got the sine of A over the sine of A equals B over the sine of B.
Okay.
And that it works the same way with sine of C. So that just leads to your law of sines there. And the nice thing is it doesn't have to be an acute triangle. You can have these other triangles here as well. But then we give them these cases where if angle A is acute, then you've got these two cases where you've got one triangle, you've got no triangle here, and you've got two triangles here. And if angle A is obtuse, you're either going to have one triangle or you're going to have no triangle.
All right.
So I will just warn you on the quiz, there will be some, especially when we get into these ambiguous cases, case 1 and case 2, where angle A is acute or obtuse. I'll probably make them some multiple choice things, and then we'll say, does this triangle even exist? And so there'll probably be some that do exist and some that don't exist, and some that are ambiguous where you can do two triangles. So
Alrighty.
so yeah, these will, so remember the ambiguous case is what we call side-side angle. So you know two sides and an angle that's not in between those two sides. Okay.
Alrighty.
Any other questions?
So are we always going to have, like, in one of the questions, is it always going to say, like, we know this, solve for angle C or solve for side C? Is it going to be like one specific thing, or is it most likely going to be solve the entire triangle?
Yes.
Okay.
It could be either case.
Okay.
I could say solve the entire triangle, which means find all the sides and all the angles. I mean,
Right.
it's nice, you know, in the first case that we did, I gave you two angles and a side. And so the nice thing about that is if I give you two angles, you can always find the third angle just because your sum of your triangles is 180. The harder case is when I give you two sides and only one angle. Then it's harder to know if the triangle even exists or if you have two triangles. But yeah, if I give you two angles and a side, that should be really, those will be the easiest ones. Any other questions? All right, how many people did we end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 people. Okay, not too bad. So I'll let Texas get started on his study group early today. How's that? Okay, well, so you have no reason not to study with Texas today because I'm letting you out 20 minutes early. How's that? Okay. So I'm going to let you guys go, and I'll try to get the quiz started early. And the homework will be on 4.1 tomorrow, and the quiz will be on 4.1 And so we'll see you all tomorrow.
Thank you.
Mm-hmm.